Optimal dispatch of power system with integrated system constraints. Abstract. This paper presents an economic load dispatch (ELD) model, incorporating wind power with thermal generator units. ELD is a fundamental issue that simulates optimal scheduling and dispatch of available generation by minimizing overall costs subjected to physical and functional constraints. Uncertain nature of wind results in the calculation of overestimation and underestimation. Forecasting of wind power is an issue in economic load dispatch. That is why the wind turbine output prediction is being done by scenario analysis method. In this, a mathematical model is used which quantifies the dispatch flexibility of thermal generation by integrating the renewable energy source, wind energy. To investigate system operations, one of the modern optimizations technique named as particle swarm optimization, PSO, is being used. The results are demonstrated on the basis of calculation of overestimation and underestimation cost factors separately. The optimization problem is numerically solved for a scenario involving 6 thermal generators units and a wind farm. Keywords: economic load dispatch, scenario analysis, wind power, penalty cost, reserve cost, particle swarm optimization. Introduction. In maximum cost-effective power system services, ELD plays a pivotal role. The goal is to reduce energy costs by meeting all physical constraints together with the energy source one. The regular increase in fuel costs, environment concerns, and the depletion of fossil fuels have prompted the inclusion of current generation in the renewable energy resources. Therefore, the integrated energy planning has become a requirement of any country for sustainable energy sector development, since economic load dispatch models helps to enhance the stochastic availability of wind power. As the production of fossil fuels reached its peak in 2015, it is now declining because, when consumed, fossil fuels can't be extracted and it takes a long geographical time to recover, keeping in view of our future demand of electricity, and to meet them alternative of fossil fuels are mandatory as wind. Wind energy is the fast-growing renewable energy source because of its abundance in nature and maturity of its technology. The main driver of this transformation is the advent of wind as the strong price winner against fossil fuels and nuclear energy as a clean source of energy. Therefore, wind energy impacts are generally seen as more environmentally friendly than thermal energy source impacts. The first important issue of wind energy is that the nature of wind, which is uncertain. 3. Because it is highly dependent on weather and geographic situations. Because of this discontinuous nature, the power generated with wind farm is uncertain and difficult to dispatch. For this reason, renewable energy source, such as wind, is overestimated and underestimated, making a mathematical model, which also quantifies the direct cost, penalty cost, and reserve cost. As India rank 4 THIN Global Wind Power Installed Capacity Index 4. In present scenario, our dependency is growing towards power, and India will require 3 to 4 times as much energy than the total energy consumed today. In order to meet the energy requirement of such a fast-growing economy, renewable energy is one and only option, because approximately 63% of total power is generated through fossil fuels, which pollutes the environment, but renewable energy accounts for approximately 33% of India's primary consumption. 5. And as of now, reducing global CO2 emissions is one of today's major challenges. 6. However, it seems more than uncertain in many parts of the world whether the objectives of the Paris Climate Agreement, PCA, will be achieved. 7. There are many options for power generation, as solar energy, supercapacitors, superconducting magnetic energy storage, wind energy storage system, hydro pump stations, compressed air system, and many more. 8. As available technology is allowing the renewable industry to achieve important milestones. In general, the future of renewable energy, and especially wind energy, is very promising, since electricity generated by wind turbines does not pollute the water we drink or the air we breathe, so wind power means less smog, less acid rain, and less emission of greenhouse gases. Because of this reason, wind energy is truly well to fulfill the objectives of Paris Climate Agreement, PCA, and providing a motivation to move towards renewable energy sources. The collective cost function of conventional thermal generators, with the consideration of renewable energy source, is considered as an economic factor. To achieve this economic factor, a day-ahead scheduling of wind is performed, for 24 hours. Moreover, an economic optimization is obtained by newly developed algorithm named as particle swarm optimization, PSO, introduced by Kennedy and Eberhard 9. The aim of this paper is to combine wind generators with traditional thermal generators to solve the problem of economic dispatch using a mathematical model. Proposed model. Unit commitment of thermal generators in the system. Where is the generated input power from conventional generators, and are the operating cost coefficient of conventional thermal units, which are obtained from input-output of generators and relies on type of fuel used as per objective function equation. For wind generators, a linear cost function is taken into account in which the wind power generation cost may not exist if the operator owns the wind-powered generators, because the output of the wind-powered generators is restricted by an upper and lower limit, decided by the system operator based on the scenario analysis method for wind forecasting. The generation of wind power varies from traditional thermal generation due to the stochastic nature of wind 12. Wind power forecasting therefore plays a key role in resolving the problems of supply balancing and demand. Precise wind power projections minimize the need for additional energy balance and reserve wind power integration capability. Tools for wind power prediction allow better transmission, planning, and thermal generators device involvement. 13. There are 3 steps in the forecasting of wind power. One of the ultimate objectives of a model of prediction of wind power is to estimate the output of the wind as early and as accurately as possible. Because overall detailed prediction of wind power reduces wind insecurities, financial and technological danger power generation. There are various methods for forecasting the production of wind power. These approaches are categorized as centered on time scales and according to numerous methodologies available in the literature. 14. They are exactly divided in 4 categories. Ultra short-term forecast, form a few minutes to 1 hr ahead. Result. In this proposed work, an economic load dispatch model is developed with the help of integration of wind farm. To investigate system operations, one of the modern optimization technique named as particle swarm optimization, PSO, has been used. The results are demonstrated on the basis of calculation of overestimation and underestimation cost factors separately. The optimization problem is numerically solved for a scenario involving 6 thermal generators units and wind farm. Conclusion. In this paper, an economic load dispatch model is developed with the help of integration of wind farm. Forecasting of wind power has been done by scenario analysis method, and uncertain nature of wind is responsible for the calculation of overestimation and underestimation factors, and model results are also demonstrated on the basis of calculation of overestimation and underestimation cost factors separately. The problem is numerically solved by using one of modern optimization algorithm, PSO, for a scenario involving 6 thermal generators units and wind farm. The results are also found to be most reliable and environmental friendlier.